All right, welcome back. So our first lesson is going to be about the real number system. So our agenda for today, make sure that you complete your attendance assignment. So I just need you to answer that response question. The video lesson that we're doing now, and then you'll have a practice assignment, a quizzes, talking about what we're going over today. All right? All right, so let's take a look at this. So we're going to be starting talking about the real number system. All numbers that we're going to be working with this year are going to be termed real numbers. So all numbers that we're going to be working with this year. All right. Those can be divided into two different systems, or two different categories, really. Irrational or rational. So some examples of irrational numbers. All right. So these are decimals that never end and have no repeating pattern. So those examples are pi, square root of 2, negative square root of 101. Those are some of those. So let's take a look at what those look like in our calculator, right? So if we type in pi, see how that doesn't repeat? And pi is also a number that just never ends. It goes out to the infinite. So we know that that is an irrational number. Let's take a look at the square root of 2. All right? See how it doesn't repeat and it just keeps on going on and on? That's why that's irrational. And then if we type in the negative square root of 101, see how that keeps on going? So it's not irrational either. Okay. The other category is rational numbers. So these are all fractions and decimals that end or have a repeated pattern. All right. So an example, here's a fraction. This is also going to be something that has a repeated pattern. I'll show you in a second. This is a decimal that ends, and this is a square root that we're going to show you what that looks like. All right. So if we look into our calculator, all right, remember a fraction is basically a division problem, right? So if we take 1 divided by 3, see how that repeats? All right, so that's going to be a rational number, okay? This one is what's called a terminating decimal. So it ends, so we know that that's rational. And if we take the square root of 16 and simplify, we get 4. All right, so that's a number that ends, so we know that that's rational. Rational numbers can be divided into 3 other things too. So we have integers, which are like our 0, 1, 2, 3, but it also includes our negative numbers, negative 1, negative 2, negative 3. Even further, we can go with whole numbers, and we just take out the negatives, right? So whole numbers, take out the negatives, still include the 0 though. And then natural numbers, take out the negatives and the 0, all right? Okay. So with that, we're going to be describing the sets that all the sets these numbers apply to, right? So since all of these are going to be real numbers, I'm just going to put a big R right here because we know that they're all real numbers. Okay. All right. So let's take a look at 30. Is it irrational? Does it never end? Have no repeating pattern? No, it ends. So we know that it's rational. Okay. Is it an integer? Yeah, I'd say it's an integer because it's a whole number, right? Oh, yeah, it's also a whole number. Sorry, I misspoke. So when I say a whole number, it just means that it doesn't have anything after a decimal point. Okay. And then natural numbers, yeah, it would work for that too. Let's take a look at number 2. All right, so negative 11. We know that it's not an irrational number because it ends, so we know it's rational. And we know it has a negative, so we know it's an integer. All right, can't be a whole number or a natural number though, because it has that negative. All right, 5 and 4/7. Well, we know that all fractions are rational numbers. All right, is it an integer? No, because it has that fraction, so it can't be any of these either. All right, square root of 21. Let's take a look at that in our calculator. See what we get. All right, so we have a decimal. Does it repeat? Doesn't look like it. So we know that this is an irrational number. What about 0? Well, that's actually already in here, right? So we know that it's rational. We know it's an integer. And we know it's a whole number, but it can't be a natural number because remember, natural numbers don't include the 0. So this is going to be Q, Z, and W. All right? What about the negative square root of 9? All right? So whenever you see a negative outside of a square root, think, okay, what's the square root of that number? And then you take the opposite of that. All right, so let's take a look at the square root of 9. All right, and we just put a negative. So negative 3 is going to be the number that we're looking at. Well, we know that that's already an integer because it's a negative number and it doesn't have a decimal. All right, so we know it's a rational and we know it's an integer. What about 6 over 3? All right, 6 divided by 3 simplifies to 2. So we know that that's a rational number. We know it's an integer. We know it's a whole number. And we also know it's a natural number. All right, number 8 should be pretty easy because it's already in our notes, right? It's an irrational number. Remember, pi is a number that never ends. So it's an irrational number. What about 5.3? And then we have this little bar over the 3. That's a repeating symbol. So 5.3 repeating. All right. So let's take a look at our notes or have a repeated pattern. So we know that is a rational number. Can't be anything else because we have that little number after a decimal point. What about this one? Square root of 144 divided by negative 3. Let's see what that is. So 144 square root is 12. 12 divided by negative 3. We get 4. All right, so we know that that is a rational number. We know that it is an integer. We know it's a whole number. And we know it's a natural number. All right, 2 more, then we're done. All right, negative 2.875. Is it irrational? Does it end? Yeah, so it can't be irrational. So we know it's rational. Do we have anything after the decimal point? Yep, so we know it can't be any of these. So it's just a rational number. All right, and then 12 is going to be a special case. We have square root of 17 divided by the square root of 17. Whenever we have a number divided by itself, it's going to simplify to 1. All right? I'll show you what that looks like. 17 square root divided by square root of 17. See how that equals 1? It's because you're taking the same value and dividing it by itself. So we know it's a rational number. We know it's an integer. We know it's a whole number. And we know it's a natural number. Okay? All right, so the quiz is just going to go over the real number system. I'd just like you to do the same thing that we did. It's going to have some check boxes. I want you to select all that apply. All right, so the link to this is on Google Classroom. Okay? If you need to get a hold of me, my contact information is going to be on the classroom as well. Okay? All right, that's it.